Okay, so good morning, Suzuki Science grade 11s. This is a lesson about probability, and we did not get a chance to do this in the correct order. So normally I'd talk about probability before we did our genetic word problems. In the interest of time, we went right to genetic word problems, so you have a chance to absorb the information, practice, practice, practice. So for those of you who are doing the distance version of the learning today, we will explore a little bit about probability. It won't take very long, and that will still give you time to practice some more genetic word problems. So if you flip a coin, you know there's a chance that you might get heads, and there's a chance you might get tails. You can see that in this graphic I have here. And I will open up a website here that you can't see me doing at the moment. Random.org, coin flip. So this way you can see what happens when I flip a coin. So on this website here, which you'll be using for a number of questions in one of the assignments, you're able to choose as many coins as you want. So I'm just going to flip one coin for now, and let's select a Canadian toonie here. All right. So when I flip this coin, there is a possibility of me getting tails, and if I flip it again, there's a possibility of me getting heads. So the question is, what is the chance that I might get heads? What is the chance I might get tails? So intuitively, many of you know the answer. You know that's going to be 50%, but are you able to calculate it? So what you want to do is you want to determine how many options you have, like I've shown you in this fraction right here. And because there is a choice of heads or tails, that gives us two options. Let me get my pen here. And I'm looking for getting tails. So there's one choice out of two options. So as a fraction, that's 1 over 2. When we deal with fractions in genetics, you can give it to us as a fraction, you can give it to us as a decimal, you can give it to us as a percent, you can even go with ratios. We've talked about that already. So there is a 50% chance that I might get tails, there's a 50% chance I might get heads. Okay? So let's say I want to convert that over into a genetic word problem. So I have two genes, I have two alleles, the gene for hair color, and I want to determine what are the chances that this parent might give a gamete that has a large B. So we have two choices, right? We have a big B and a small b. So two choices, and I want to know what the chances are of getting a black allele. So that's one choice. So that means there's a 50% chance of getting the black allele. And by the same token, there's also a 1 out of 2 chance of getting the blonde allele. All right? So now let's extend that and make that a little bit more complicated. Let's say that I want to figure out what are the chances of me getting two tails. Okay? So in the first flip, we already determined that there is a 50% chance. So our fraction is 1 over 2. Okay, so that's the chance of getting a tail. And I want to know the chance of getting a second tail, which is also 1 over 2. So when I have two fractions like this, what I'm going to do is I'm going to multiply them. So the chances of me getting two tails is going to be 1 over 4, or 25%. All right? So now let's extend that to our genetic word problem here. Here I have two genes, one for eye color, which is my A, and one for hair color, which is my letter B. I want to determine what are the chances that this parent here might produce a gamete that has two capital letters. So a big A and a big B. Okay, so what are the chances? So the chances are, well, let's take a look. The chance of getting this big A, there are two options. Okay, so this program's not working very well. I'm going to switch over to my whiteboard. It'll just be easier. I should have put everything on this in the first place. Okay. So once again, I'll just rewrite that question. Big A. So here's the parent, and I want to know what are the chances that they could produce this gamete. So there's a chance of getting this big A. There's two possibilities because it's a big A and a small a, one choice. And for the B, there's two possibilities, a big B and a small b, and there's one choice. So when I multiply those two together, it's 1 over 4, or 25%. So the chances that this parent here might produce this gamete, big A and big B, is 25%. And so I can take this concept and I can keep on extending it and extending it and extending it and extending it, right? So I could go to a question that looks at 3, right? H, I, and J. Okay, so let's go back to my whiteboard here. I would like to know if I have a parent that looks like this. I'll use a different color. Big H, small h, big I, big J, small j. Actually, let's make it a little bit different here. Yeah, let's make it a little bit different. So I'm not going to give you the same format I've just given you. I'm going to give you something different here. So let's go with big H, big I, big J, and big J. Okay? I'd like to know what are the chances of producing a gamete that has a big H, a small I, and a big J. Alright? So the chances of getting this big H, there's 2 possibilities, 1 choice. The chances of getting this small I, there's 2 possibilities, 1 choice. Chances of getting this J, there's 1 possibility, 1 choice. So when I multiply this whole thing out, I end up with 1 over 4. So there's a 0.25 chance, or 25% chance, I can get this gamete, big H, small I, big J, from this parent. And that's how you work the probability. So you'll see that there's a genetic problem worksheet. If you understand what I'm talking about here, it'll probably take you about 5-10 minutes at the most to work your way through these questions. You'll see some that go up to 4 genes, like this one here. 11 is just a logic problem, so it relies on the same principle, but you don't need me to teach you to figure that one out. But 1 through 10, they are genetic word problems that rely on probability. Now, that's only the first part of the probability. We also have the chi-square. So I'm going to make a separate video, so we have 2 small videos. So this is probability, and the second video will be on chi-square, and I'll keep it separate.